In this video, we try to understand the process of alternating series test through this problem. The summation of a negative 1 to the nth power times the square root of n over n plus 3 as n start from 1 to infinite. This is an alternating series, so by using alternating series test, the first step, we need to take the limit of a b sub n as n goes to infinite to see whether this is going to go to 0. Again, when we say b sub n is this item right here. This is called b sub n. Okay, we are going to verify the limit of a square root of n over n plus 3. I think this can be verified algebraically, which is we're going to divide by square root of n on top and the bottom, square root of n, and this is going to be n over square root of n plus 3 over square root of n. We simplify that. On the numerator, I have just 1. In the denominator, I will have n divided by square root of n is square root of n plus 3 over square root of n. As n goes to infinite, we get to know this goes to 0. As n goes to infinite, we get to know square root of n is going to go to infinite. Therefore, 1 over infinite is going to go to 0. And that's how we verified the limit of b sub n is going to go to 0. And the second, we need to verify this is a decreasing in terms of an infinite series. Means we like to know b sub n plus 1 is less than b sub n. And we like to know whether this is true. So this needs to be verified rather than just stated. To do so, the easiest way or easier approach, let's define this as a function, square root of x over x plus 3. We're going to take the derivative for this function. The derivative of the function, we are going to square the bottom function. On top, we are going to take the derivative of the top function first. The derivative of square root of x is going to be 1 over 2 square root of x times the bottom function, x plus 3, minus the top function times the derivative of the bottom function, which is 1. Square root of x, sorry. This is a square root of x. And now I'd like to simplify this before we carry the discussion a little bit further. I am going to multiply the top and the bottom by square root of 2x. And now I will have 2 square root of x times x plus 3 quantity square. On the numerator, let's look into these two terms. We are going to distribute this item through the brackets into these two terms. When you multiply 2 square root of x onto the first term, and 2 square root of x will get cancelled. So I only have x plus 3 left. And the second, when we multiply square root of x, 2 square root of x, and we will have minus 2x. So once we simplify this, I will have a negative x plus 3 over 2 square root of x, x plus 3 quantity square. Okay, we're going to save some space. Okay, I'm going to squeeze this all the way to the corner here. And this means the derivative of the function is going to be less than 0 if the numerator, negative x plus 3, is less than 0, right? Because the denominator is always positive. And that means only if x is greater than 3. So under this condition, and then we get to know b sub n plus 1 is going to be less than b sub n. So b sub n plus 1 is going to be less than b sub n for all n that's greater than 3. So it means from fourth term on, you do have an decreasing in terms of an infinite series. And this concludes our discussion. We say therefore, the infinite series converges by alternating series test. Okay, next, just for the fun of it, and we are going to look into what do you mean when you say Sn is greater than 3. So the way we verify this, let's write down the first few terms for this infinite series. So the first few terms, let's see, negative 1 to the n, square root of n over n plus 3. As n goes start from 1 to infinite, the first term is when n is 1. When n is 1, I will have a negative term, right? Because when n is 1, negative 1 to the first, that's going to be negative. So when n is 1, I will have square root of 1 over 1 plus 3, that's 4. Next term is going to be positive, square root 2 over 5, square root 3 over 6. And that's going to be, this is going to be minus. Okay, this is going to be minus. And the plus square root 4 over 7 minus square root 5 over 8, and the plus square root 6 over 9, and the so on and so forth. Remember the condition we put on the alternating series to be convergent for n is greater than or equal to 3 means after we pass by these first 3 terms, I should have decreasing in terms of infinite series. So that in reality, if you look into it, you just work out the first few terms just to verify our theory. And if you work it out, the first term for let's see, the first item right here, square root of 1 over 4, that's 1 over 4, which is 0.25. So negative 0.25. And then you work on the next one, square root 2 over 5. I think I work it out to be 0.2828. As you can see, the numerical value is going up. Minus square root 3 over 6. We work this out to be 0.2887. Think, as you can see, the numerical value is still going up. And we are at, so I have minus, plus, minus. Now I should have a plus square root 4 over 7. Square root 4 over 7 is going to be 0.2857. You can see the numerical value is going down now. So what about next one? Root 5 over 8 is going to be 0.2795. Okay, that looks good. It's still going down. And the next one is going to be root 6 over 9. I think that's going to be 0.2722. So this is it, decreasing in terms of an infinite series from this point on. So that verified our condition. So make sure on the test, when you go through the process, you do need to carry out this process logically. The first step, we need to verify limit of b sub n. The second step, we need to verify b sub n plus 1 is less than b sub n. Rather than stating it, stating is not enough. You need to verify. The way we verify, for this question anyway, we set up a function, we take the derivative of the function. We like to see the derivative function to be negative so that it's a decreasing function, and therefore I can imply I have a decreasing in terms of an infinite series. But this is going to be true for only n is greater than 3. And then we conclude, we say, okay, the infinite series, the alternating series converges. I hope this helps.